Welcome to our introduction to research data management, and we now want to focus a little bit on why we want to establish data-centric workflows. So let's discuss a bit why do we want to bother with RDM at all. On one end, we can see data as a foundation. Most properties that ultimately we're interested in are inherently stochastic in nature, so it requires either statistical modeling or, for example, machine learning or AI tools. That in turn require a large amount of data that we need to build these models. So if we want to focus on the so-called meaningful work or the scientific questions we want to address, we need to be able to easily capture the data, but also automate our workflows. Furthermore, if we're able to share data, we can both benefit from work of others and also enable more analyses or others to improve on our work. Also, we need to spend a lot of time on working on data quality. That is essential if we want to build data-centric workflows. Also, research data management helps us to enable reproducible science. We need to be able to track the provenance of, for example, samples or our tools or the software that we use, and we can define standard operating procedures so we're able to reproduce the workflows. In the end, that helps us to establish some quality control. And last but not least, there's also external pressure for us to invest in research data management by funding agencies and other external bodies. So our challenges are quite manifold. We have an enormous range of methods and approaches in the same collaborative effort. On the theory and simulation side, we already deal with structured data, and this structure sort of leads itself to an obvious metadata schema. This makes it, well, not simple, but in turn we have already an approach on how to track and store and query the data. Of course, that becomes more challenging if we do it on a large scale and have many heterogeneous compute environments or big data. Also, this needs to be integrated with all the other data that we have, and this brings us to experiment and analysis. Especially in our CRC or SFB, we have a very wide range of methods, from more physical or methods that really we do by hand to mathematical analysis and machine learning. These manual processes encompass, for example, casting, grinding, polishing, and many other aspects. There are also many steps that we need to take to come from like the raw ingredient or sample to the final analysis. And we want to formalize this in standard operating procedures so we can achieve some consistency across time and also researchers. But this is not all. We also have many experimental devices that are not yet routinely tracked and integrated in our RDM approach. And each of these scientific instruments have proprietary data formats. Furthermore, we also have many software environments that we use for simulation or analysis that are also not quite yet routinely tracked and integrated in our RDM system. So let's look at a very simplified example. Here we see a complete workflow with many steps omitted, of course, where we go from the casting of a sample to the experimental analysis to the final analysis of the sample using, for example, machine learning or electron microscope imaging. So what do? We cast the sample, so we have a set of experimental samples, but we also may have different samples that may or may not be split in subsample or different parent-child relationships. So we need to be able to track if we, for example, cut our sample in several pieces, which of the pieces belong together to the same original sample. So here we need to establish some sort of hierarchies. Then each sample will have some unique history depending on what has been done to the sample, for example, a heat treatment, rolling, and so on, or tensile testing. So that means that we need to have a sample management and inventory, and each of these samples need to be tracked with a unique code. And then we do our many experiments. We have a lot of devices that we use for these, and we also have a lot of procedures that we need to follow to conduct the experiments. So here we need to be able to track both the experimental devices and scientific instruments that we use, but we also need to be able to track what procedures we have followed to conduct these experiments. And then finally, we all need to be able to link this together. So which experimental sample has been used in which experiment, what procedures have been followed to conduct this experiment, and which machines or instruments have been used. And all of this needs to be entered into an electronic laboratory notebook. Furthermore, some of the experiments may produce quite a large amount of data, so we need to be able to handle this amount of data as well. Once we have summarized all of this, we have already created in the first phase of the CRC a metadata schema that needs to be amended in the second phase. This metadata schema essentially is a way to formalize the complex relationship between the experiments or measurements, the devices, the sample, and the procedures, and each of those comes with specific properties. So shall we say in informal database lingo, a schema is essentially a set of relationships between tables that capture all this information. So that brings us to a lot of the technical requirements that we have for an RDM system. So first of all, we need a relational data model. So here we can make use of our defined metadata schema, and we can have, for example, relationships between parent and child samples, between the experiments and the samples that were conducted, and so on. And this allows us to also conduct complex queries. For example, which experiments have been done with a sort of mother sample and all the subsequent children? Or if I have a sample, what was the entire history of this sample? An electronic lab box helps to capture this information. It needs to be integrated into this relational data model so that the workflow between entering the relationship between samples, experiments, procedures, and devices can be maintained in the web interface. We also need access to big data storage, at least for some projects, and we would need a way to automate the data ingestion and metadata handling from experimental devices, because many of our scientific instruments already capture a lot of metadata, and we need to be able to capture these automatically in the RDM system. Furthermore, we want to be able to share data, not only within our collaboration, but also publicly with others and publish data. And we also want to have convenient access for our analysis later on. And as we've mentioned before, we need urgent access to sample management so that we can track what has been done to a specific sample and crucially also where the sample actually is. There's also a community aspect. We need to establish a common language across the CRC, and this enabled us already in the first phase to establish a common metadata schema. From this, we now want to move on to enable our standard operating procedures and formalize our experience that we have in conducting the experience, and want to integrate this into our daily workflows in the electronic lab notebooks. That makes it easier to also incorporate data quality, and that becomes more crucial for the later analysis or machine learning or AI applications. And these requirements essentially mean that we need to settle on the OpenVis framework, especially for the experimental workload, because this software is able to capture all our requirements. However, what have we now done? So far we've generated a lot of extra work for each and every one of us. And of course that makes us a better scientist and allows us for a more reproducible science. But so far we've entered a lot of data to the RDM system, but if we don't use it, it doesn't really help us. So what do we want to do? First of all, we want to have an efficient access to all the data across the CRC so that we can use all the data to, for example, build our defect phase diagrams or other analysis. But we also want to help to improve the analysis workflows and automate where we can automate workflows. This helps us to alleviate the burden to do everything manually, and it also helps us that if we enter new data, we can just sort of trigger this automated workflow and have it run automatically. And finally, we also want to enable larger scale analysis and move away from manually sharing code or data and use the RDM system as a centralized facility to help us conduct the experiments and the analysis much easier than we can do so far. So this brings us to a short summary. The RDM system allows us to track experimental data and simulation workflows. For example, which samples were used in which experiments, how these samples were treated, what kind of procedures they have experienced, what experiments have been done, and so on. The RDM system allows us to put everything into one place so we can track all relevant information and make it easier to share this information with others. Furthermore, it allows us to build data-centric workflows and automate our daily work as much as possible so we can focus less on the tedious part of handling data and more on the scientific big questions. And also, one other more practical aspect is that if we use such a combined RDM system, we can also take care of data safety centrally. For example, then you would not experience a data loss if, for example, a lab computer goes down.